Now in this video, I have a 5-volt peak-to-peak sinusoidal input. My frequency is 474 Hertz. I've got a 200 ohm resistor in series with a 140 ohm resistor, a 47 millihenry inductor. The reactance of my inductor is 140 ohms J. Now the reason I've got these lines around my inductor and my resistor is because sometimes the inductor will come in one package with a series resistance built into the inductor. Now what I'm going to do is I'm going to show you how to find the total impedance of the circuit when you have an inductor and a resistor in one package in series with a resistance of some value. Now what I'm going to do is I'm going to act like this 200 ohm resistance and this 140 ohm resistance is really just one resistor. So I'm going to add the two values. So I've got 200 ohms plus 140 ohms. That equals 340 ohms. Now, this 140 ohms is my resistance. That is not to be confused with my 140 ohm J, which is reactance. Now what I'm going to do is I'm going to add my 340 ohms onto my 140 ohm J. So I'm going to go Z total equals 340 ohms plus 140 ohms J. Now what I'm going to do is I'm going to plug these two values as written into my calculator. $340 plus 140 ohms J equals my calculator gives me 367 ohms and an angle of 22.38 degrees. Now I'm going to find my total current. I equals 5 volts over 367 ohms. And that equals 13.62 milliamps. Now I will find my voltage across my resistor. $13.62 milliamps times 200 ohms. That gives me a voltage of 2.72 volts. Now I will find my voltage across my 140 ohm resistor. $13.62 milliamps times 140 ohms. $1.9 volts. And since my reactance is the same as my resistance, the voltage across my inductor is also 1.9 volts. And this brings me to the end of the video. Subscribe, like, share. Subscribe, like, share. Thanks for your attention.